In this video, I'm going to use properties of 30, 60, 90 special right triangles to solve problems. You should check out prior videos to see where these properties come from and why they are the way they are. In this video, I'm going to just recap and state what they are, and then use those properties to solve some example problems. A 30, 60, 90 right triangle might look something like this, where we have a right angle, a 30-degree angle, and a 60-degree angle. We said in the prior video that this comes from splitting an equilateral triangle in half with an altitude. So this side of the original equilateral triangle is the hypotenuse, and then the side that was cut in half is this side that's across from the 30-degree angle. We call this side the shorter side, or the short leg. And we said if this was, say, length x, then the hypotenuse is twice as long as this. So a formula for that would be 2x's. And we used the Pythagorean theorem to show that this altitude, or the longer leg, which is across from the 60-degree angle, is whatever the short leg is times the square root of 3 this time. So with this relationship in mind, with the relationship stated here, if you know any one part, then we can work backwards to find all the other parts of this special 30, 60, 90 right triangle. And we're going to do that in 3 examples here. In this first example, we know that the short leg, the side that's across from the 30-degree angle, happens to be the square root of 3. The longer leg is this x that we're looking for, and the relationship between the two is that the longer leg is just the short leg times the square root of 3. Or in this case, if I fill in what I know, the longer leg is x, the short leg is the square root of 3, and I need to multiply it by another square root of 3. Square root of 9, which is just 3. If you need to find the hypotenuse as well, you could take the shorter leg and double it. So the hypotenuse happens to be 2 squares of 3. In this right triangle, the side that I know is across from the right angle is the hypotenuse. This tells me from my relationship that the easiest side to find is going to be the shorter leg, because I'm just going to take the hypotenuse and cut it in half, because the hypotenuse is twice as big as the short leg. The short leg is across from the 30-degree angle. The 30-degree angle must be here, which means that the short leg is y. So the short leg is half of the hypotenuse. The short leg is 15. If you know the short leg, then the longer leg is just that value times the square root of 3. The longer leg is across from 60. That means this has got to be the longer leg. So x is the longer leg and is whatever the short leg is times the square root of 3. Lastly, here's an example where in this case I know what the longer leg is. This is the one situation where there might be a little bit of algebra to use to simplify to find the missing parts, but it's well within our grasp. Again, the relationship is the longer leg is whatever the short leg is times the square root of 3. I know the short leg is x because it's opposite of the 30-degree angle. So to find what x is, I need to divide by whatever number is here. In this case, it's root 3. X is 9 divided by root 3. We need to rationalize this, so I should multiply by top and bottom by this denominator, by this square root in the denominator. That ends up being 9 roots of 3 over square root of 9, which is the whole number 3. And 9 divided by 3 is 3. So x is 3 roots of 3. X is the shorter of the two legs. The hypotenuse is the shorter leg times 2. The hypotenuse in this case happens to be y. So this tells me that y is twice as big as 3 roots of 3, which is 6 roots of 3.